So my name is Karthik. I'm an associate professor in computer science. I direct the Center for Embodied Autonomy and Robotics. I also direct the master's program in robotics at UB. I direct the drones lab. We recently have transformed into doing a lot of field robotics work. The main projects that are going on in my lab is there is a project in collaboration with Moog where we are working on excavation autonomy. This project is broadly called Earth. The second project is in collaboration with the New York Canals Corporation, where we are doing canal inspection with legged robots. And the third project, which is just about ramping up, is to do with assisting archaeologists on where to dig. This uses drones to identify subsurface structure, so we understand where the archaeologists should go and dig. Those are the three main projects in my group. Yeah, so many of these are very application focused. So I feel like robot autonomy is at a place where we can not just do cool demos, but actually assist other things. So in each of these applications, we do various things. A specific emphasis in my group is robot perception. This is what has been historically. So the use of computer vision, machine learning for with robots to assist something. So in the case of the excavation autonomy, how are you able to see this unstructured environment and then navigate yourself in an unstructured environment, particularly a big robot like an excavator, and then excavate or dig at places where you want to dig. So all of these have perception challenges, but also control challenges. The same thing with the culvert inspection or the canal inspection. The legged robot has to make its way down the canal, so down the bank of a canal to the culvert, and then go into what is like a tunnel. The culverts are like tunnels. So making its way through that, and then it's very low lit. So being able to perceive what is happening, detect things like cracks and spalling and seepage and so on in that environment. So with collaborations with companies like Moog or other branches of state government like the New York Canals Corporation, we are bringing robots and autonomy to their application. And so I would say a lot of the work in my lab is very application or domain focused. So like I said, so there are a few thrusts. So I told you my interest is in robot perception. So recently we are particularly interested in the use of Gaussian splatting, which is a way of doing, of representing the scene. So your camera captures a bunch of images, but how do you represent that? And historically, we've been interested in both the visual appeal as well as the 3D structure. And Gaussian splatting is a particular representation that combines both of these. So we are studying the use of Gaussian splatting for a variety of applications. The other thrust has been safety. So how do you, when you're doing control planning, how do you do safe control, safe planning? So again, as I mentioned up front, a lot of my interest is in taking robotics and autonomy to a domain. So there is a lot of collaboration. So the work with Moog is in collaboration with this company. They have specific interests where they are deploying these excavators. And so we try and collaborate with them in those aspects. Similarly, with the New York Canals Corporation, the archaeology work is in collaboration with a faculty member in the Department of Classics. He is the expert archaeologist, but we are assisting him in helping him automate or make autonomous some of the pieces, discovering aspects. In my research, I strongly collaborate with other faculty in engineering, including folks in mechanical aerospace engineering, industrial systems engineering, and so on. Yeah, so my teaching is sort of informed by my research. I am very interested in hands-on experience in research. I strongly feel that the only way you can teach robotics is by making students do robotics. So I'm specifically a computer science professor. So when I say robotics, my perspective is in the software up. I don't do a lot of building. So the course I teach primarily is CSE 468, 568 robotics algorithms. This is a required course for all the MS robotics students, but is also a course available for ME, AE, CSE students, and even so both at the undergraduate level and the graduate level. There are also many aspects of working in robotics that are not just technical. So I engage in both these ways. Separately, I think to train roboticists, we need to understand various implications of robotics. So AI ethics, robot ethics is a big topic. The legality and so on is a big topic. So I tend to engage with other folks who have those expertise. So legal, ethical, social, and so on for various aspects of robotics. So my lab typically employs or has a bunch of undergraduate and master students working with the PhD students I already have on the various projects. The best way is usually to take my course, CSE 468, 568 robotics algorithms, and that gives you a good baseline background for what happened in my group. It is also a required course for both the master's in robotics program, but also the undergraduate minor in robotics. Other backgrounds we could use are if you have taken the computer vision image processing course, CSE 473, 573, or the machine learning course, CSE 474, 574, deep learning, reinforcement learning. So if you've taken any of these courses and done well, that is usually a good start to get into the group. Almost always there is some amount of learning that happens in the group that is specific to the things we do. So students that come in spend a month or two, depending on how quickly they adapt, to ramp up. And then we have specific tasks for students. I think research in robotics is a subset of just doing robotics. My strong advice is robotics is a combination of theory and practice. So wherever there's an opportunity, don't just stick to the theory, but also do practice. As I mentioned, we have lots of openings. Almost every semester I send out email looking for both undergraduate and master students. A lot of the opportunities, the basic requirement is that you have some background, say a course in robotic algorithms, computer vision, machine learning, or one of the other branches of learning, deep learning, reinforcement learning, or even background in optimization, control, and the three big projects are the ones I mentioned: excavation autonomy, legged robot inspection, and then aerial vehicle coordination. And based on your interest, you can come join one of those. They're typically led by my postdocs and PhD students, so you'll have close mentoring as you make your way through the research, sort of through the basics, and then they will sort of pick the specific tasks at hand at any given point.